So let us study about sound here. What is sound? Sound is a wave. Sound is a wave. And what is a wave? Wave is a disturbance that travels. Wave is a disturbance that travels. So here, when the disturbance travels, how is this different from the other kind of motion we call particle motion? When there is a particle, if you apply force on this particle, the particle itself moves from one place to another place. When the particle moves from one place to another place, this particle carries energy and the capacity to destruct, or we call impact factor, momentum. So momentum is carried by particle as the particle travel from one place to another place. But when a wave travels, the particles do not move from one place to another place, rather the particles just vibrate. Particles just vibrate in wave motion. What kind of a vibration? Suppose imagine there is a wooden plank and you just hammer this wooden plank here. If you just hammer the wooden plank here, when you hit and if you place your ear here, what happens? You will be able to hear the vibration or the disturbance produced here. So the disturbance created by this hammer traveled on this wooden plank to this point. So the traveling took place in this direction. So the disturbance is created here, but it traveled to this point. Suppose if the disturbance here is very strong and if you place a glass tumbler or something, so it might even break it. So it will topple it. So the ability of this disturbance as this travel along this, it can also create some impact. That is why wave motion carry energy and momentum. Like particle motion, wave motion also or a wave also carry energy and momentum. Waves carry energy as well as momentum. So momentum is the measure of impact, the ability to impact, the ability to create impact. So the disturbance that travels is called a wave, and we just said that particles just vibrate. How many kinds of vibrations possible? Suppose if the wave travels this way, the particles can vibrate this way. This is called along this direction of the wave. This is to and fro motion, to and fro motion. And sometimes when the wave is traveling this way, the particles travel perpendicular to the wave because the angle between this vibration and this direction is 90 degree. This kind of vibration is up down vibration, up down motion. This is to and fro motion, this is up and down motion. So there are two kinds of wave motion. I mean, the particles vibrate. There are two kinds of vibrations possible when a wave travels. Based on that, we categorize waves in two types. One is longitudinal waves, longitudinal waves. The other one is transverse waves, transverse waves. So what is a transverse wave? Suppose there is a free surface of water and if you throw a stone here, you will find that ripples form. These ripples slowly grow in size. That means that the disturbance created here is traveling in this direction, is traveling in this direction, it's traveling in this direction. That is why it is growing in all directions. So actually the disturbance created at one place is traveling in straight line in all the directions. This is the wave motion. This is called transverse wave because if you look at the surface of water, you will find that the water will have ups and downs here, and the wave that is created here is traveling in this direction, whereas the particles just move up and down. That is why they produce crest, the upper point and the lower point, the crest and trough. This kind of waves are called transverse waves. What is a longitudinal waves? To understand longitudinal waves, just imagine a slinky, a large kind of bangle which is in the form of a spring. Suppose this is that slinky. You just place, fix the slinky at both the ends. Here you compress 2 3 springs in one side. After compressing this, when you release, the compressed spring suddenly expand. When it expands, it will compress the next few springs here, and then those compressed springs expand and then again compress next few springs here, and so on. So at one point of time you will find there will be compression, there will be elongation, there will be compression, there will be elongation, and finally what happens, whatever disturbance you created here will travel up till this point. Here the springs actually compress and expand in this direction, but the wave is also traveling in the same direction. This kind of wave motion is called longitudinal wave motion. See, what we are trying to understand is sound, but because sound is a wave, it is very important for us to understand what is a wave. When a particle moves from one place to another place, it carries energy and momentum. That is very obvious. But when the vibration alone travels, how does it carry energy and momentum? Just imagine we are able to just produce electrical energy using the wave motion, right? Moreover, when the waves come and bang at the shore, you will see that it exerts force. It can produce some impact. That's why we said waves carry energy as well as momentum. And waves, as such, they can be classified into two types: longitudinal waves and transverse waves. A transverse wave is something, the direction of the wave and direction of vibration of the particle are perpendicular to each other. This is direction of the wave. Direction of the wave propagation, we can call it wave propagation. The direction of wave propagation, this is the particle vibrating. The particle is not actually moving along with the wave, it is just vibrating. This is direction of vibration. Direction of vibration. So this direction of vibration and direction of propagation are perpendicular to each other. That is a transverse wave. In longitudinal wave, direction of vibration and direction of propagation are parallel to each other. So direction of vibration of the particle, direction of vibration, and direction of propagation, of the wave are parallel to each other. Here it is parallel. In longitudinal wave it is parallel. Here it is 90-degree, means perpendicular. So perpendicular. In case of transverse waves, it is perpendicular. So we have understood in simple terms. Let us summarize again. Sound is a wave, and wave is a vibration that travels, and there are, as the vibration travels, it carry energy and momentum. And waves can be classified into two types: longitudinal and transverse. There is also another kind of wave that we have. Light is supposed to be a wave. But there is the sun and here is the earth. Nearly 15 crore kilometer distance they are apart. 15 crore kilometer they are apart. And there is only a small region where the atmosphere is there. Atmosphere contains air. But in between there is nothing. That means vacuum only is present. When in through this nothingness, light travels from the sun to the earth. So without even the requirement of any medium, the light wave travels from the sun to earth. That is very obvious that we can see. So what kind of a wave is that? So again, based on this notion, we are classifying waves into two types: mechanical waves, mechanical waves, and non-mechanical waves. What is a non-mechanical wave? Light is a non-mechanical wave because light does not require medium for propagation. So for propagation, no medium is required. No material medium is required. No material medium is required for propagation. This is called a non-mechanical wave. Whereas mechanical waves require medium for propagation, require medium for traveling. Sound is a, if light is a non-mechanical wave, sound is a mechanical wave. Suppose if it is the moon and this is the moon, from the moon surface, you, if there are two persons, they can't even breathe because there is no atmosphere. These two persons cannot hear each other because since there is no atmosphere, even if there is a bomb that is going off here, if the person is trying to talk to him, the sound will not go to him because no medium is there. So sound, for sound to travel, we require medium, and that is why sound is a mechanical wave, whereas light is a non-mechanical wave. So far, what we have seen is sound. So we have to right now focus on sound. So what have we understood about sound? Sound is a wave. This sound cannot travel without medium, so it is a mechanical wave. Mechanical wave. But what kind of a wave in case of whether sound is a longitudinal wave or a transverse wave? Suppose if it is a solid, if it is a solid at the surface, suppose if you hit this solid with some object, vibration is produced. This vibration travel in this direction. At the surface, sound travel in the form of transverse wave at the surface. But here beneath, inside solids, sound as travels as longitudinal waves. Longitudinal waves. So this is the highlight. Because sound is a wave, this wave is a mechanical wave in general. Whether if you ask whether it is a transverse wave or longitudinal wave, it depends on that. What is that? In solid, sound is actually both longitudinal wave and transverse wave. In liquids and gases, it is only longitudinal in nature, longitudinal wave. So sound in general, sound is a wave, and that is a mechanical wave because it requires medium for propagation. Through vacuum it cannot travel. Without air or solid or liquid or gas, it cannot travel. In solid, it travels as both longitudinal wave and transverse wave, whereas in liquids and gases, it travels only in the form of longitudinal wave. If you compare the speed, what is the speed of sound? Speed of sound. So in air, sound travels with only 330 to 340 meters per second. That means only one third of a kilometer per second. But in water, sound travels with a speed of about 1500 meter per second or 1.5 kilometer per second. But in solids, respectively, speeds depends on the material of the solid. If the material is very solid, it can travel few tens of kilometer per second. So it is high, more than the speed, more than the speed in liquids and gases. In liquids and gases. So this is all about sound. So sound is a mechanical wave. Sound travels in the form of both longitudinal and transverse in solids, but in liquids and gases it travels only in the form of longitudinal waves. But sound struggles to travel faster in air. It travels only 1/3 of a kilometer per second, whereas in water the speed is nearly 5 times the air, 5 times in the sense nearly 1.5 kilometers per second in air, but in solids it travels even faster than these two. This is the whole thing or the whole knowledge that we need to know about sound as such. In the next class we will discuss about some of the important characteristics of wave, that is frequency, wavelength and amplitude. Based on that, let us also categorize sound. Okay.